Hey everybody, it's Mrs. Cassill, and welcome to your motion terminology self-test. This really is a practice assignment, but it's going to count as your quiz for this week. What I want to do is kind of go through the notes we would have reviewed if we were in class together before we started something like this. And then during class, we would have been helping each other. I would have walked around, I would have answered your questions. Because we don't have the option of that right now, instead, I thought I'd record a perfect run through so that you can see how this self-test works and then also see how to use the physics that we have barely covered in order to work through the problems that are presented, okay? So the first thing that I want to do is I want to kind of think through what the big ideas are that are going to be covered in here. We're going to see a bunch of our keywords like distance. We're going to see displacement. You're going to see speed, and you're going to see velocity. So if you are watching this video right now, hoping for help in how to do this assignment, the first thing I would recommend is that you open your notebook and look for your notes that includes these four words, both their meaning and the math. So distance, great way to think about it, is the total ground covered. So we're going to be examining some objects on a trip. Here, I can move this out of the way of my little face up there. Displacement, however, is the change in position. So sometimes an object might get up and move around a lot, like I can get up and leave my chair, right? So I'm taking a bunch of steps. I can walk around over here. I can wave in the camera. I can go over here. Climb over my chair. Oh my gosh, it's very so lean over here. This is the spare room. It's full of weird items like, books that nobody reads anymore and literally every gift bag that I've ever been given. So, yes, I have a problem. So, here I am back in my chair. I took 17 steps around the room. So, the total ground I covered is going to be 17 steps worth of ground. But my displacement, look where I am. My initial position was in this chair. My final position is in this chair. That means when I compare where I started to where I ended, I moved 0. My displacement, how much out of my starting place I am, is 0. Think about it another way. Imagine you closed your eyes while I did all that like leaning and leaping around this room instead. You wouldn't know if I moved or not. If I turned off my camera and just made a bunch of like, oh, dang it, I kicked that. Oops, I got to climb over my chair. You wouldn't know, right? So displacement is a change in position. One of the important things to remember is it can be a positive or a negative number. Distance is always going to be a positive number. Speed and velocity are looking at the distance divided by time. So if I'm thinking about how fast I was moving while I wandered around that room, well, I went 17 steps, and I could go back in this video and watch the seconds on the timestamp tick by and see how much time it took. 17 steps divided by that time is going to tell me what my speed is. Velocity, on the other hand, is displacement divided by time. Displacement divided by time. In class, I make mistakes too, so this is very real. Displacement divided by time. So here, if somebody who runs the 400-meter race, they might have an incredibly high speed. So if they run that 400-meter race in 60 seconds, good job. So they've got 400 meters was their distance divided by 60 seconds of time. That's going to give you their speed in meters per second. Velocity, however, is a physics term. It includes this idea of displacement, not distance. So somebody running the 400-meter race around a track, so all the way around a track, so they get back to the same starting line, their displacement is 0. Their velocity for that race is 0 meters per second. Their speed might be great, but their velocity can be small. And that's an important thing to pay attention to as we go through this today. So, a couple things that we will look at for going through this simulation here. So these basic definitions, and notice I didn't really write them as equations, I wrote them as ideas, but they're going to be what helps me find out the answers to these questions. Notice a few things. Total is a math word, right? How do you find the total of something? You're going to add. How do you find the change between two numbers in math? That's a difference. This means you're going to subtract. And these are pretty easy. Divided by and divided by. I guess I should go by. Divided by and divided by mean divided by. I'm going to take this number, figure it out, and divide it by a time, right? So those are the basic ideas I need in order to answer these questions. All right. I don't think there's anything else that you need to prepare in advance. So I'm going to go ahead and go over to my simulation here. And I'm going to put in my name, Mrs. Cassell, and I'm going to begin the simulation. See, it says you will be presented with objects moving along a number line. You must be able to answer 10 questions correctly in a row to pass this self-test. When you're ready to start, click the begin button. And when you've achieved 10 in a row, you'll be prompted for your name to share your results with your teacher. You will need to take a screenshot. I put a video in Canvas to show you how. So let's go ahead and begin. So this Pac-Man Ghost started here. This is position 0. It's cruising along super slow to position 1 right here, and then it turned around and went backwards to position 2, right? This is a great one that I got here because these are all tiny numbers and they're all negative numbers. Your ghosts are going to move differently when you do this. They might go all the way across the number line. They might start in the positive end and end on the negative end. It's unique that mine is all over here. But here we go. Actually, because these are both 4 seconds, you know what? I'm going to go ahead and refresh this. Not because I don't want to do this one, but I want to get an example with different time intervals. So that way, ooh, look, my ghost is going faster this time. Zipping all the way over here. Ooh, up to the positive numbers. And then back over here. Ooh, also for 4 seconds though. So I guess I have to take it. I'm not going to make you watch through another one of those. So here we go. My first question. So let me analyze what this screen says. So first, it says from position 0 to position 1, the time is 4 seconds. So if I go down and I look on my number line, here's position 0 at -8. You watched it, rewind if you're not sure. My ghost went all the way over here, and it took 4 seconds for it to do that trip. From here, position 1, which is at 3 on my number line, back to position 2, which is at -5 on my number line. It says from position 1 to 2, it also took 4 seconds. Right? So from here to here, it took 4 seconds. From here to here, it took 4 seconds. So now we're just going to dig into the problems. And I'm going to write out my work. If you haven't written this down, rewind, pause, write it down, because I'm just going to slide at my page so I can have room to write everything. Okay, so what is the average speed for the first leg of the trip? Here's my question. What is the average speed for the first leg of the trip? Well, I know that speed is going to be distance divided by time. So I'm going to try to figure out what my distance is and figure out what my time is. And it says for the first leg of the trip. So that means from position 0 to position 1. That first leg is what I'm analyzing here. So I need to figure out what my distance is. It's going to be from -8 over to +3. So 2 options here. You could count this on the number line. You could actually count how far it goes. 1, 2, 3, 4, 5. I'm not going to do that. Or you could do some subtraction to find distance and compare your final time minus your initial, or excuse me, your final position minus your initial position, since we're looking at just one leg. So my distance, I'll write it down here. My distance is going to be equal to position 1 minus position 0. So if I look at what my position 1 is, that's at a positive 3 minus my initial position, which is a negative 8. Whenever I have subtracting a negative number, that's the same as adding. So my distance is 11 meters. The time it took, the problem tells me right up here, is 4 seconds. So if I want to know what my speed is for number 1, my speed is going to be equal to 11 meters for my distance divided by 4 seconds. I'm going to have to do that on a calculator, so I'm just going to pull my calculator. Calculator, there we go. I'm going to do 11 divided by 4, 2.75 meters per second. So there's my answer. Notice it's a positive number. It's important to pay attention to. So I'm going to come over here, find my positive number. What do you know? I got 1 for my correct answer. It's not very super flashy when you get the right answer, so you got to pay attention. So I clicked 1, and now I have a score of 1. I'm trying to get a score of 10. What was the average speed for the entire trip? Okay, average speed for the entire trip. Well, if I want to know what my average speed is for number 2 here, this is the entire trip, right? So my speed, oh, excuse me, calculator. Calculator, would you go somewhere else? My face is in the way. I couldn't minimize that. So for number 2, I'm looking for my average speed for the entire trip. I'm going to be looking for what's my total distance for the entire trip. And I want to look at my total time. And remember I said earlier that the word total, this is a math word, this means add, right? If I want to find out what the total is for something, and sorry, while the ink is wet, it's super glowy up here, but it's what I got. I want to go ahead and add these numbers to find a total distance and a total time. All right, well, I already know that my distance, for example, is going to be 11, because I found that in my first problem, plus whatever the distance is for the second leg of my trip. So let's figure that out. So my second leg of my trip is from position 1 to position 2. So here I go from 1 back to position 2. I'm going from 3 to negative 5. So that distance, let's figure that one out. So my distance for position 2, for leg 2, is going to be my final position, which is from negative 5 to minus where I started, which is 3. This is a negative 8 meters. Now here's an important piece. I've put a negative here because I'm keeping track of where my position actually is. But a reminder, when we talked about the total ground covered up here, we said it's always a positive number. So right down here where I figured out that, gosh, the second leg of my trip was negative 8 meters, it's always positive when we're talking about distance. So my total distance was 11 plus 8. Ooh, I can do that math in my head. My total distance is going to be 19 meters. Okay? Because I had 11 meters plus 8 meters. My total time, that's pretty easy. I've got 4 seconds for the first leg, 4 seconds for the second leg. So I've got 8 meters. Seconds. It's very late at night when I'm recording this. You'll see once I post it, for those of you who care about my well-being. So I've got 11 plus 8 is 19 meters divided by 8 seconds. Again, I'm going to use my calculator to do that. So I've got 19 divided by 8 equals 2.37 meters per second. This is a positive number. You'll see that there's a 2.38. Please don't panic. That means somebody rounded this. I left off the 5, that's why. Because there's my calculator saying it's 2.375. So they just rounded it differently. That's fine. I'm going to click it. Look at that. I got 2 points. All right, my next question. What was the turning point, the turning position of the object? When did the object change directions? All right, well, it was going this way from position 0 to position 1. That's one leg of the journey. And then it changed directions when it got to position 1, because then it headed back to position 2. So where was it at this turning point? It was at 3 meters. Oop. I'm doing pretty good so far. I feel good about myself. What was the average speed for the second leg of the trip? Okay, we're getting lots of speed questions on mine. You might get speed questions, you might get displacement questions, you might get distance questions. So I'm looking for the speed for the second leg of the trip. I'll put a little 2 down there so that I know. And sorry that my camera keeps trying to focus. As you all know, technology is helpful, sort of. So I've got my speed for the second leg of my trip is going to be the distance for the second leg of the trip divided by the time for the second leg of the trip. So I'm putting those 2's down there. Listen to the words I'm saying too to make sure you understand. I'm just keeping track of what they are. Okay, well, I figured out my distance was 8 meters in the last part of this problem, or in the last problem is right up here. There's my 8 meters. Rewind if you're not sure. And then my time is 4 seconds. Ooh, that's an easy one. 2 meters per second is going to be my speed. That's a positive number. There we go. What was the ending position of the object? Well, I ended at position 2, which is over here at -5. All right. What was the average velocity? Okay, now we're getting into something where our negative and positive is really going to be important. I realize this is not question 4, but it's my 4th calculation, so I'm just trying to keep track. What was the average velocity for the first leg of the trip? So, velocity, spelled correctly, that's an I right there. That's a lowercase letter I. I don't know if you can tell that because, things. Velocity is equal to displacement over time. It's our first velocity question, so I want to make sure we pay attention to this. Displacement can be positive or negative. So I'm going to do a quick check. The first leg of the trip, I was moving this way, which is towards the positive numbers on my number line. So I know that I'm going to have a positive velocity if I do my math right. So I need to figure out what was my displacement. It might be the same as the distance I already found, might be different. I don't want to assume, I want to be clear. Displacement is a change in position. We use the symbol delta x to represent displacement, and we calculate it by saying my final position, where did I end up, minus my initial position, where did I start. So I want to know what this displacement is. My final position, so I'm looking at the first leg of my trip, that's going to be position 1 over here, is a positive 3 minus my initial position, which was position 0, is a negative 8. So my displacement is going to be positive 3 minus minus 8, or 11 meters in the positive direction. That makes sense. So I can go ahead and put that number then back up here, because I already know what my time is, because it's given in the problem. 11, a positive 11 meters divided by 4 seconds is going to be equal to the speed that I found the first time, 2.75 meters per second. And I'm just going to be very careful. That's a positive number. So my velocity for the first leg of the trip is positive 2.75 meters per second. So that's D. I'm going to say it here. What was the average velocity for the entire trip? Okay, now we've got one that's different. So now I want to know my velocity for the whole trip. So I need to find my total displacement. Oh, I'm going to run into my previous line of writing, sorry. Divided by my total time. Again, this is where physics, while it might seem confusing in the first place, does something really helpful for us. The equation to calculate displacement is the same, no matter whether it's the total displacement for the entire trip or a partial displacement for a leg of the trip. If I want to know displacement, I'm just talking about where did I start and where did I end. In this case, where did I start the very beginning of the trip and where did I end the very end of the trip? Well, I started here at -8 and I ended here at -5. So if I want to find my total displacement, that's my final position minus my initial position, which is -5. That's my final position. So where my ghost ended is right here at -5 minus my initial position, which was a -8. You can always use your calculator. It's a great tool, right? If the negative numbers have you spooked, use your calculator. Otherwise, the math you learned is good math. When I subtract a negative, that's the same as adding. -5 plus 8 is 3 meters. So my displacement for this entire trip is a positive, I should make sure, -5 plus 8, yeah, that's a positive 3 meters. If I want to know what my velocity is then, I'm going to put that number back up here. I'll just rewrite it down below because it's getting a little crazy pants. My velocity for the entire trip is going to be positive 3 meters divided by 4 plus 4 is 8 seconds. And yes, that's a fraction, but I believe in decimals. I can find decimal on a ruler, so you know that's what I'm gonna do. 3 divided by 8, 0.375 meters per second. That's a positive divided by a positive. So I'm just going to make sure it's a positive number. Look over here. Sure enough, oh, you can see they rounded, right? So here we go. This is a positive. There's a negative over here, but I'm checking my work. Oh, it helps if I move my calculator here. Calculator, excuse me. So here we go. So I'm checking my work. There it is. This is my answer. Okay. So I'm doing pretty good. I'm up to the whatever this number is, number 7. I've got a few more to go. So I'm going to find a new page in my notebook, which is super full at the moment. Hopefully won't bother anybody, but it's got Elaine scribbles all over it. So, you know, welcome to the life of being a teacher and a mom at the same time. So it's pretty fun. Okay, so now, what was the starting position of the object? So that's easy. Where did I start? Position 0 is where I began. That's back here at -8. Let's look at one. Ooh, what was the distance traveled for the entire trip? So I found that on the previous problem. Remember, I found that from point 0 to position 1, that this was a distance traveled of 11. And that from here, position 1 back to position 2, that this was a distance traveled of 8. So my total distance was 19 meters. I just want to go back and double check. Because here's what happens if you click the wrong answer. It makes you redo the whole thing again. Hang on, where's my paper? I was just writing on it. This is why you should do your notebook in order. So for any of you who are like, I just write on a random page, that's what I've been doing, and look at what it's costing me right now. Just gonna check. Oh yeah, here we go. I've got it. I'm gonna use a new color. What kind of color? Over here, I've got my total distance. This is pink. This is red. Come on. I've got my total distance right here was 19 meters. And click that. What was the displacement for the entire trip? Ooh, I just found that down here. When I had to calculate my velocity, I found my displacement for the entire trip right here was a positive 3 meters. So there we go, positive 3 meters. Oops, helps if I click. Mrs. Cassill, you have successfully completed the motion terminology self-test. It required 17.33 minutes to complete this activity. Some of you are going to do it in less time, some of you are going to do it in more, and you can redo this as many times as you need to until you get 10 out of 10. What I want you to do once you've gotten 10 out of 10 is you're going to take a screenshot of your certificate here so that you can turn this in. So that way you'll be able to save this and upload this on Canvas. So that is how you will get your points for this assignment. Again, this will count as your test for Friday. If you aren't somebody who usually writes out your work, I want to encourage you to do so. You could do all this on your calculator, but look what happened when I got to questions that asked me to revisit the something I'd already calculated. I didn't have to work through it again. I didn't run the risk of making more mistakes. I could go back and look through my work and find out where I calculated distance, where I calculated displacement, right? So anyway, that's how you do this assignment. I hope that helps. Please don't hesitate to reach out if you need more help, all right? Now I will figure out how to stop this recording, and I hope you all have a great day.